Hello, everyone, and welcome to our third workshop of our Datathon and machine learning competition. My name is Daniel Mieling. Just keep in mind this session will be recorded as the last two ones as well. So today we move to the second part of the Datathon challenge using our pre-annotated datasets, aka our gold standard to train and evaluate a machine learning model. And that serves the purpose to basically create a system or build a system that allows you to automatically detect anti-Semitic content. So just keep in mind, this is our final workshop where you learn the basics for NLP. Don't worry, you don't need to be an expert in NLP. We walk you through the key concepts and some practical steps. And just keep in mind, as always, it's more important that you work together as a team and document everything thoroughly. And we also encourage you to think critically when it comes to this subject. So what happened so far? In the first workshop, my colleague Gunther Jikeli introduced the patterns and forms of anti-Semitism in online discourse, and especially in relation to the events after October 7. And that first workshop gave us the conceptual foundation for identifying and classifying anti-Semitic content. And in the second workshop, we had a hands-on walkthrough where you basically learned how to scrape your own data by using the Bright Data dashboard, how to pre-process it by using Google Colab, and to upload it on our annotation portal. So if you have missed one of those two sessions, just have a look on the right-hand side of this slide. We have, at least for session one, the slides ready for you. And we have also a video tutorial for workshop number 2 ready on YouTube. Just check the GitHub repo. Everything you need is stored and documented there. So our today's session is about, as I mentioned already, learning the basics about natural language processing and automated detection systems. First of all, I want to give you an overview of what we expect you to submit as a team. First of all, to work on and then to submit later. I also give you then a little overview about the timeline and the submission process. And then in the third and fourth part, you will meet your instructor for today's session. And he will guide you through then the basics of NLP and model training. And in the last part, we then come back from our breakout sessions, and we have time for Q&A. So if you have any immediate questions, I guess it's always good to ask them, but I suggest to postpone them until we are done with the main workshop. So challenge number 2 asks you to use our pre-annotated data sets to train a transformer model, as I mentioned. And your model can be based on any major transformer architecture. Just check our GitHub repo, where we also posted some recommendations what models might be suitable for the task. So on the right-hand side, you basically see the key links. Again, from the top to the bottom, the challenge description itself, and the link to our annotation portal, the GitHub repo. And as you can't click on these links right now, I just post the link to that PowerPoint that I'm currently showing to you in the chat. So just make sure to check those links before you proceed. So again, challenge number 1 requires you to use one or more of our pre-annotated gold standard data sets to build and evaluate a transformer model. And this means training the model in order to make it possible to automatically classify whether a given post, a social media post, contains anti-Semitic content. And these data sets are useful because we made sure that there is no discrepancy involved. That means we had two people working on the same content, and everything where the assessment of the content was not aligning with the other annotator, we basically forced them, quote unquote, to discuss the discrepancies. So we made sure that the annotations are accurate. You find the links. You find the links in the PowerPoint slide. So all you have to do is basically click on those, then download the data, and you can either choose one or combine both data sets. That's up to you, and depends on your modeling strategy. And all data sets include user-generated content from the platform X. And they were, by the way, I introduced you to a schema last week where we applied the arrow working definition to annotate the material, and all the annotations within those two data sets were done by using the same schema that I showed you last week. Okay, let's now go over what you are expected to do for challenge number 2. So first, you download one or more of the pre-annotated data sets, then you use a state-of-the-art transformer model to train and to fine-tune a classifier. You can choose your own architecture, like anything that is connected to BERT should be fine. And then what's very important is we are asking you to report your results by using standard classification metrics. So these include, for example, precision, recall, and F1 score. And if it's possible for you to do that, we would be also happy if you provide a confusion matrix to help us to interpret the misclassifications of your model. You should also list all the hyperparameters you used. So basically the learning rate and the number of epochs for the model training. And you should also report on a little error analysis. In other words, where did your model perform good, or where did it perform wrong? So you can just show us a few false positives or ambiguous cases in that section of your report. So in short, you just pick a data set, choose and fine-tune a transform model, and work toward a system that can reliably detect anti-Semitic content. Once the model is trained, just make sure that you clearly document everything that you have done, or also the things that didn't work out that well. So just, for example, document what model you used, how you trained it. And this includes, for example, the details of your train and test split, the random seed, any pre-processing steps that were involved, and the training strategy you applied. And this helps us then to us as our team evaluates the submissions, then to make sure that everything that has been submitted is transparent and makes it possible to reproduce your results. So your submission should either include a script or notebook that allows us to rerun your model on our end. So that means you have to basically include your training scripts, your configuration files, and any custom pre-processing steps. Very important, you can also earn up to 10 bonus points by testing your model on unseen data. So you should all have access to BrightData, to the dashboard that I introduced to you last week. And the credits that you have or should have left allow you to scrape at least that what I was told, up to 10,000 additional tweets. So you basically can just scrape more data if you want, and then basically use your well, you have to do an additional annotations then, of course, but then you basically use those annotations to fine tune your model again. Right, and just make sure that you briefly reflect on everything, how well it worked, how well it generalized, and would also document what did not work as you expected. So here's a quick reminder of our timeline. So today we are already in the third and final workshop for challenge number 2. And the submission deadline for for both challenges, I was asked in advance if you have to submit challenge number 1 today. No, you don't. Just submit everything together in a comprehensive report. So your submission deadline is August 5th. And you should, if you haven't already finished, now towards the end for challenge number 1, and start working by the end of today's workshop with challenge number 2. So now I'd like to introduce you and hand things over to our instructor for today. His name is Professor Damir Cavar. He's a professor at Indiana University, Bloomington, and he will lead the 3rd workshop. And he's an expert in computational linguistics and machine learning. And his work underpins the technical side of the Datathon, especially around the basics of machine learning and natural language processing. So Damir, we are very happy that you joined us today, and we look forward to your input. And if you're ready, the floor is yours.
Yes, thank you. It's good to be here. Actually, this is like, I believe, the 4th time that I'm participating in one of these hackathons. Let me share the screen from my side. What I wanted to do is basically just talk in general about what we are doing and the ways we approach these problems, detecting hate speech, anti-Semitism, and other issues in social media using NLP and AI technologies. I'll introduce some stuff, not go into the details how you will train your transformer models, but show you some techniques that we use and some new approaches that we are switching to slowly, given the current AI technologies, the large language models, generative AI, how this can be used for classification and information extraction from social media. So if you want to ask questions, you can just go ahead and ask whenever you think there's something unclear. So what are we talking about? That's the first step, the research resources that I usually recommend, where you can find information beyond just basic search, of course, and then what the goals are of what I wanted to present today, and present then different methods and examples by showing you some notebooks, and you can download those and play around with those online. So I am in linguistics. I'm working on natural language processing, usually play around right now with large language models and RAGs, retrieval augmented generation. I'm interested mainly in computational semantics, meaning representations, and how we can reason and apply logic over data, things that people say in social media, for example. And I use quantum computing as well. So there's a conference, if any of you is interested, come on the 6th of August, 7th and 8th here in Indiana, in Bloomington, and join us at the NLP Quantum Conference. Now, the textbooks that I use, my favorite is Jurafsky and Martin's Speech and Language Processing. If you click on the link We'll share the slides with you. You'll get to the website. You can download the textbook for free. It's a PDF, freely accessible. Other than that, if you click on these links, the search terms that I defined here, you will get the overview of ACL anthology articles that talk about anti-Semitism, archive articles, and Semantic Scholar. This gives you an overview of what currently people are talking or what they published on in this domain from a more engineering and technical perspective. These are just links to the search interface actually on these websites, and you can search there yourself. The code, this was actually, it is 25, so there's a typo. This should be 25 here. The link takes you to the 25. There's a GitHub repo of Python tutorials and notebooks that I share freely on my GitHub repo that is parts of these things that we are looking at today. You can access those freely as well. There are some repos that talk about anti-Semitism outside of this project here, and hate speech and offensive language datasets in general on Kaggle, for example, that one can look at how people solved certain problems, what the challenges were, and so on. So for today, basically what I prepared, and we can skip over some stuff because I can imagine that some of you are experts in this domain anyway. We can just go quickly over something like a Boolean labeler for biased, unbiased, or anti-Semitic yes or no, binary decisions over content, and how one does that statistically. Boolean classifiers like this one here, this is basically just using Bayesian statistics, which is a different kind of approach compared to the other technologies that we're using. And then another issue here would be, for example, do we have any NLP and AI tools that can help us with annotations, that can help us to suggest labels with something like a human in the loop strategy, where, you know, we feed in a sequence of tweets and the system tells us you should consider this to be anti-Semitic or not. It's a version of a classifier, but in a very different way. I'll show you some examples of what that could be. The other levels are basically, we could run these tweets through extractions, extract entities, identify the concepts that are mentioned, extract something like triples, subjects, predicate, objects. I'll not go into detail there, but just say a little bit about how you could do that. And then you could, for example, use new technologies to identify, you know, if the classifier says that this is probably anti-Semitic, what are maybe slurs and pejorative words, phrases, derogatory terms in there, and so on. Give me a list out, such approaches, and then, you know, structure all that in JSON or some other format so that you can ingest that into a database, for example, and work with that. The machine learning approaches that are sort of from baseline Bayesian models over to a little bit more advanced logistic regression, but sort of still a baseline for machine learning. If you compare any other model, you should use those as, you know, this is with very simple means. We can achieve that kind of classification and then compare your transformer model, for example, if it's BERT based on or based on derivatives of the BERT model, how you outperform the basic base standard like logistic regression. I'll show you quickly how that works and what that is. The other stuff is basically when you're dealing with classifiers and you want to sort of train a transformer-based classifier or any kind of neural model, you would want to deal with word and text embeddings, and there are different models that provide you those. BERT has its own, but large language models allow you to pull embeddings from those, and you could compare basically whether the larger vector representations for words and text in large language models like GPT-4, like Claude 4, and so on, are maybe perform better in neural models or architectures. I will show you how to pull such vectors and how to play around with them. And then we could look into Spacey as an NLP platform where you can actually, interact with large language models as well as with BERT. You can train a transformer model with Spacey as well. And using Hugging Face as a repository as well as a tool to pull models and vectors and so on. Show you how to use Voyage AI, which is basically the repository, the company that produces the embeddings for Anthropic, Claude, and OpenAI and so on. You might be experts in that anyway, so we'll have to just skip. If anybody says this is boring, stop. Just shout out here. For large language models, I'll give you examples how to interact with OpenAI and Anthropic to pull vectors and to actually interact with the model directly to use it as a classifier or to extract information. Same thing is possible with Google's AI Studio or with Llama directly. You can download Llama and run it on your local machine. You can use environments like Ollama to pull various large language models and operate them on a normal PC if you don't have a GPU, for example. LM Studio allows you to do that as well. GPT4All and Gen and so on. All these tools are basically there to allow you to sort of like democratization tools for large language models to allow you to run them locally. So the basic architecture, if we use sort of like what we are talking about, text and data sets, social media data in particular, to train models on, what needs to happen is we need a pre-processing phase. We have to clean out the data, remove some noise in the text, for example, and then provide data labeling. And this is what you got, I think, in this project with the gold standard labeled data set for anti-Semitism. And what you do then is you split the data set into two sections. One is a training data set and the other one a test data set. You could sort of decide to have the one 80% and the other one 20%. And then you can apply all kinds of learning algorithms from simple text frequency minus inverse document frequency, TF-IDF, to part of speech tagging, to bag of word extraction, and so on, for classification statistical models. Or you pull word embeddings from different models, GloVe, Elmo, Word2Vec, or BERT, or now GPT and Claude, and train a model, a neural model, transformer-based model, for example, as in the task that Daniel described here. And then you would come up with a decision, hate versus non-hate, anti-Semitism versus not, and so on. That's the general approach. And then you measure your accuracies using some evaluation based on the human-provided annotations like an F1 score. If you switch to another approach, this is basically using LLMs, that is much simpler now. We basically just have a data collection, we send it to an LLM, and we get classification results. There's no interaction modeling, no necessary large-scale training. We can apply that as a zero-shot task to GPT-4 or Claude 4 and so on. If we want to have some kind of fine-tuning and mini training integrated as a pre-step, we could do a few-shot approach, and I'll show you examples and code how to run that with Claude and with GPT. And you provide a bit of context, some examples, how somebody annotated, what the gold standard annotations are, and then you see what the LLM tells you. And so, of course, with an LLM, there's far more behind there. So there's a huge model where we have pre-trained LLM models, and then we have an API, and we have few-shot learning and all kinds of stuff. You have a specific prompting approach that you have to sort of figure out yourself, what is the best prompting to give me the best results. You can add domain knowledge in various ways using, as I mentioned already, what I'm working on is RAGs, retrieval augmented generation, where what you do is you just provide more context to the LLM to give it, to bias it towards a specific analysis or result. So what I have is basically some Python notebooks, and I wanted to walk you through them, and we can go through some faster or slower, depends on what the status of you guys is, whether you understand everything. So I'll switch to that, and then you tell me and you interrupt me with, you know, if it's too slow, too fast, or whether we should discuss something in more detail. Okay. So I'll share now just the code window. I hope that this is readable. Is this okay for everybody?
You could make it a little bit larger or zoom in, that would be good. I think it's a little bit too small.
What happens when I shrink the window size? Is this visible for you? So let me just start this one here. Does this look okay for everybody?
That's good.
Okay, good. So here's a very simple example. This is just a Bayesian classifier, just to go through, discuss a little bit the differences and slowly introduce the LLM style approach. So here, for example, if I want to have a classifier, I'm just using NLTK here. So if you want to install NLTK, the Natural Language Toolkit, you get certain kind of components that help you with this code. With classifiers, I define spam text, say, for example, here, by just providing a text that mentions all kinds of crazy words that typically occur in spam. And just load the Python module. I have just one message here in spam that's important. Then I have ham mails, which are just common emails that people send me that shouldn't be classified as spam mail. And now you could consider spam ham as the classification problem that we are confronted with when we are looking at anti-Semitic, non-anti-Semitic as a classification approach to social media. And we have one spam mail and 4 ham mails, right? And we could just, this is just showing you, normalize the text. We could say we lowercase it, so that if we lowercase it, what we could do is run a frequency analysis and just extract a frequency profile through all of these documents, right? And this is what this thing here is doing. So it's tokenizing the text and lowercasing it, and what we are getting back is basically the lowercase tokenized version of the first ham mail, right? And we could then run a counter on the tokens. So I know that in ham, for example, I would get twice this and twice test and teach once and so on. So this is just generating your frequency profile, right? So that much is clear. So what we want to do is just generate a frequency profile of tokens through text, and then we can do that for spam and ham. And we have now 2 different probability distributions or frequency distributions over words. And we know that if there's somewhere something like Viagra or whatever kind of boldness and so on, all kinds of things that occur in spam will less likely occur in ham. That's sort of the intuition that we have. And what we can do now is just relativize the frequency profile. So this is just dividing by the total. So what I get now is the probability of, if I randomly pick a word from a text from ham, the likelihood, or here in this case, it should be spam, the likelihood that I pick medicine is 4.6%, right? And so that's just sort of to relativize and generate these frequency profiles. And what I do then is basically I calculate how likely is it that I pick a spam mail from my data set, from my corpus, and it's 20%. How likely is it that I pick ham as 80%? And so now, in order to compute the likelihood that a certain text that is unknown is ham or spam, what I would have to do is just compute the likelihood that these sequences of words are coming from this particular model. And this is what this explains. If you read the text later, if you're interested in that, it shows you or explains you how we compute that. And here I have some sample text that says, dear Hans, I have not seen you for so long. Well, we'll go for a coffee. And I get basically the result for spam, and I get the result for ham. No, the result for spam, sorry, and the result for ham. And what I can say now is basically, is it spam or ham? And in this case, the model, since it had just few data sets, it just wrongly says it's spam. You could correct this and play around with that. This is just to say this is one of the approaches. We have an a priori data set where we basically divide the data into two groups, spam and ham, and we extract a probability distribution of tokens from that data set and use this as a model. And then if we have an unknown document, we try to figure out how likely is this document generated from the one or the other model, right? An alternative approach here would be, here's an example of a simple document classification using scikit-learn and logistic regression. So we have a data set, and this is, I have a link there. I can show you quickly what that looks like. This is the corpus. That's the Amazon review data set that is shared on Kaggle. I have a link to that here in this notebook, and the label is just the prefix to the text, and one review is the text in one line. So line by line, what you have is label and then following the review text. And this is just sort of reading that data in, and what we do is we split it into labels and text, aligned to aligned lists, and we can print this out. So we have now sort of like the first three lines from that. We use pandas to generate a data frame, and in this data frame we will store the texts and the labels as two columns, and we can now do a scikit-learn model selection. And what we do is basically in the model selection we tell scikit-learn to split our corpus into a test corpus and a training corpus, where we get back here the training text, the test text, the training labels, the test labels. What we provide is basically just the list of texts and the list of labels aligned. And we want to specify how big. So here we just say 1/3 of that we want to use as the test corpus for our model evaluation. And you can play around with that size as well. So now we have basically a training text collection and a test text collection, and we can use an encoder to encode the labels, which is basically we want the labels to be 0 or 1 simply, rather than complex labels as in the corpus as such. I mentioned that this is like this string underscore underscore label underscore underscore and then 1 or 2, for example, in this specific data set. And so now we have just for the first 10, we see here that the labels are converted to 0s and 1s, and we can now fit the data using logistic regression, for example, to generate the labels for, or generate a model for our classifier. And we have a count vectorizer that is, in this case, basically just per text, we are mapping the frequency of words along the columns. So we are generating for every text a vector, and every column corresponds to a particular word that occurs in our entire corpus, and it will be the frequency count. So it's a very simple approach, and this vectorizer generates as these vectors. We can print that out. I don't want to go into details here. And then we have to transform the text into these vectors. so that we can then train a linear model that gives us logistic regression as a classifier over these document sets. And in the end, we can measure how good is this classifier now. We could print the details out, but this one approach gives us something like 86% of accuracy. So whatever you're training afterwards, you should beat that, because this is one of the most simple classifiers that you can find statistically. Details about all that you could read on these links. There's a documentation page about how this vectorizer works, and you can now use all kinds of other alternative methods. So in order to vectorize a text, for example, you could imagine that what you're doing is, here in this case, we're just looking at word frequencies, right? So we're looking at what words occur in a specific text, and we count them, and we use this as a classification criterion. But we could manually engineer that, right? So we could say, well, if there is one of these common slur words, if there is one of these bad words occurring in this text, we add a flag for that in a vector representation, and so on, right? We could include there a feature that tracks people who are known by their profile name to post bad content and so on, and hate speech. So we could manually engineer such vectors to get classifiers trained on these models. Now, for all the transformer models and so on, what we do is we convert strings, words, and so on into vectors, and just so that you get an idea what these vectors are and what they look like. This is a notebook that describes that. So it's just using BERT actually to pull vectors for words. I'm just using a random seed and running PyTorch with my GPU here. And there's a function get embedding, and what that does is basically it just takes a string, which could be a word or a sentence, for example, runs it through the tokenizer and asks a specific model to give us back a BERT type model to give us back a vector representation for that word. So here I'm defining that I want to use the uncased tokenizer for BERT and the uncased model, and I'm sending it the word test and getting back the length of the vector. And oh, I did not print the length of the vector. So the vector length here is 768 dimensions. So this is the common vector length for BERT models. The more advanced models, all LLMs have now a vector length of 3,000 and upwards. It goes in some models up to 10,000 dimensions. So they are very large vectors. And I can create now a word list like here, apple, banana, cherry, and so on. And I could pull all the vectors for all these words from the model, and now you see that there's basically something like a randomly looking distribution of real numbers that encodes the meaning, and we could now use the dot product, for example, and measure the distance in linear algebra between hamster and rabbit, and banana and apple, for example, and then compare, do semantic correlations, semantic similarities correspond to geometrical similarities or distances. And the idea is these vectors, the embeddings, they were trained in BERT by maximizing, so to speak, the likelihood of vectors in the context in a sentence to maximally predict the missing word in between. So if you're familiar with second language acquisition tasks, what people were doing, they would give you a sentence, and then erase one word, maybe a verb, and your task would be to reconstruct the missing word to test whether you understand Spanish or French well, right? This is a common test. Well, these models, BERT, were trained on exactly this task. We would mask a word, and then we would train the vectors around this word to maximally predict the correct missing word. Which means in the end, the result is that these vectors should reflect semantic similarities. So goldfish and trout should be more similar. The dot product should be reflecting the semantic similarity versus goldfish and car, for example. Right? So these vectors are semantic vectors reflecting semantic properties and similarities. And you can pull them from BERT, which means that now you can use them in your neural model. If you want to build a classifier, you can actually push a text to BERT and you get back a vector representation. And then you can train a classifier that says 0 or 1 as output, for 0 being not anti-Semitic and 1 being anti-Semitic, for example. There are transformers, other transformer models that you can use on Hugging Face, for example, that give you already a basic classifier. Here in this case, I'm just using the Transformers Python module, and I'm building a classifier that says it's a zero-shot classification, and I want to use Facebook's BERT large model. And here's a sequence of words. We like the code to use code for Python, but Vim for C. And we just introduce labels ourselves. Words like automotive, programming, politics, economy, okay? And we want to know now which of these words fits best with this context, right? And so you see already yourself that it should be actually programming. So if I now run this, I can actually run the classifier. And you see here that programming is the highest score. It's almost 90% similar to this text here, right? And all the others are below 10%. Get the idea? So this is a zero-shot classifier using BERT. And the way you could manipulate that is actually, let's just take this here, and we could add our own text. And I prepared some stuff here, for example. Let me just do this. That's a real example from the gold standard data set. And so what we could do here is or say neutral.
Just one thing about that comment, Damir.
Yeah.
I think that it should be mentioned that it's a very overt comment. Like it doesn't, like it expresses clearly, or it includes language that's basically considered hate speech, right?
Right.
So
right.
very often
Exactly.
it's the case that you have covert examples
Right.
that basically include conceptualizations that express a certain idea, but not explicitly. So therefore, that is one of the difficulties when it comes to anti-Semitic content, that depending on the platform, the language can be different drastically. And of course,
Absolutely.
that
Yes.
example is maybe a good one to basically say, well, that leads, when you annotate such content, to a shared decision making, right? So you basically classify it as probably biased or anti-Semitic, but it's very often the case that you are not so sure about it, or don't, or have a different access level to certain kind of knowledge, and therefore you basically differ in your assessment of the material. And that is one of the biggest problems when it comes to hate speech detection.
Yeah. So this is basically absolutely clear. It shows us exactly what it should. Anti-Semitic is actually the most likely label that the BERT model, without any training or further tuning, would assign to this text, right? And love gets something like less than 1% likelihood as fitting, right? So that is exactly what we expect. So it's just saying that this is the approach that you want to do, that you want to apply. For example, in a zero-shot scenario, you have just basically multiple labels that you want to assign to some text. In this case, the task is actually much simpler because we are only dealing with a binary classifier, but this is a tool that would allow you to actually have a multi-label classifier, and you would have to define your own threshold where you want to stop, right? Good. This is just so further of these examples, and this one is the multi-label classifier that just does exactly that. So if you have multiple of these labels, it would then tell you which ones fit and so on with a certain threshold. Good. That's transformer-based, embedding-based type of classifiers. The more advanced type of models right now are using, for example, vectors that come from very large language models. Gosh, I don't know. Doesn't matter. Okay, here we go. So these large language models use of course, the whole internet to be trained on all the text that is available, and they use typically very large vector lengths. Voyage AI is the company that does the vector embeddings for Anthropic. Anthropic is the company that builds Claude 4, and I will show you Claude 4 in a second, is the most recent version of their AI that can be used for all kinds of interesting tasks in our scenario here when we are talking about anti-Semitism in social media. And I'm just loading the Voyage 3 large vectors and connecting to the API. You know that if you get this notebook and you want to play with these and also pull your own vectors, you have to create an API key with them. And it might cost you a few cents. It's really, really cheap to get these vectors. And you can use them also in the same type of transformer model as BERT vectors and so on for similarity. That's a function that just gets some word list and pulls the vectors for these words. And this one saves them in a CSV file on disk so that you don't have to pull them multiple times. If you have done that already, you save some dollars. Here are the vectors, the words for which we will pull the vectors and save them then in the Voyage embedding CSV file so that we can then compute some similarity scores. And you see this is a very fast interactive API. And this is the CSV file with the vectors, and you have here basically it's just the first line is the header of the CSV file, the second line is dog, and then you see the entire vector length for dog, and this is now double the length or up to 3 times actually of the BERT vectors. So this is much larger vectors, and the idea there is that we can store far more semantic information and correlation information about words in such large vectors. GPT-4 in 4.1.0 uses 3,000 dimensions. In the newer models, they were talking about 10,000 dimensions. This is just a way to pull these vector representations for a text or a list of words, whatever you want to deal with. And then the same thing exists for, no, it's the Claude thing for GPT, no, OpenAI vectors. They have different kinds of models, of course, and you can test and play around with those as well. You can decide which model. Here I'm taking the embedding 3 large, which is about, I believe, 3,000 dimensions big. I connect to the client. I get the embeddings for a word list here from the specific client. Here's my word list, and I'm pulling these vectors, and those here I'm just printing. You see how that would work, and then you would basically keep those, compute with them. I'm doing this here now for one word, but you can do this for a whole paragraph. You can do this with an entire tweet, actually. The tokenizers here are very different. It's not tokenizing on the basis of strings of words or so. It's using a bytecode encoded tokenizer, so it can process all kinds of pictograms as well and stuff like that in tweets. So it's useful to use alternative embeddings other than BERT, for example, and play around with that. I mean, comparisons would be very interesting. Now, let's use some AI, really interact with those. So these are the vectors from the AI, good. Entropic vectors, I can save that too. But here's a test interaction with GPT that we could use, for example, to in our task. And I'm switching here to 4.0, the version from November. Again, you need an API key for that. I can't unfortunately share mine. I'm a poor professor, but if you register, you might have some, I don't know, credit to use some of that. The call to the GPT function requires a prompt. I actually split off an instruction part so that it's clear that we have an instruction and a prompt, and we can model and change those directly. And here's a target tweet, for example, that I also pulled from the gold standard. And I will not tell you what the label is. Now, what I want to do is I want to ask, let's actually just do the word wrap so that we see better, and do the word wrap here. I want to ask the model what it thinks. Given this tweet, I'm asking, judge the following social media tweets for anti-Semitism. I should just say tweet is just one. Respond with 1 if the following tweet is anti-Semitic, and with 0 if it is not. Do not provide explanations, just return 1 or 0. You interacted with ChatGPT and so on, you know that it's very verbose. It starts talking to you and chatting and explaining stuff. We are not interested in that. In these APIs, we just want to have 1 or 0, right? So that we can actually program with that, and we can pull this into a database or an Excel data sheet, right? And let me see, I have to run this target tweet, and I get a prompt which says 0. So has a right to self-defense. I don't know, but Hamas, the only democracy. I don't know what it was. Actually, I didn't write this down, what the human judgment was on this tweet. Now, that's already something you could do. You could run this. You can play around with the instructions. If you change the instructions and the prompts, you might get different results. That's sort of like this part of experimental prompt engineering and so on. But you can actually process this way, actually, an entire database quickly and get an annotation from the LLM directly that you could use for, improving your own results on a classifier, for example. Now, this is what we call a zero-shot test or zero-shot experiment. We're just giving it the example, and we are asking a concrete question, but we are not tuning it by telling it, here are some examples that you should look at, right? So this is in the second part here. What I'm saying is, this is a few-shot test. So I'm saying, here is a tweet, and here is the instructions. So it says, judge the following social media tweet for anti-Semitism, respond with 1. It's the same thing, just return 1 or 0, right? But I say, here are some examples provided by human annotators. And those are from the gold standard data set, right? I give it the tweet and I give it an answer. And now here I provide just 4. I mean, you can expand that actually with 10 examples and see where you get the best responses. Get the idea, right? So here are two tweets that were judged by humans to not be anti-Semitic, and these 2 were judged by humans in the gold standard data set to be anti-Semitic. Okay.
One question from my end. So when do you consider something a few shot, and when is it basically then a fine tuning? Because you just have here 4 examples, which is considered a few shot, but what is actually like the verge basically where you say, okay, this is going beyond a few shot?
Yeah, so fine tuning, you know, the system as such has multiple components, right? So there's the model in the back end that is basically next word prediction as an underlying model that takes vectors and runs them through layers of transformers and gives you an output vector, right, for the next word that should continue the text. Now there's a specific learning algorithm afterwards that learns from your judgments, and you can sort of tell it, no, this was wrong, this was true, this is correct, and you can actually give it corrections. So you could tune at both levels, actually. You could tune the model at predicting the next word by actually piping more context through it and tuning specific outside layers, or you could tune it in what people call the alignment section, where you align with a specific question answering task or with a special classification or judgment task and so on. You should check this out. There are various ways how you could tune it. The easiest here is basically provide a context, and we could add to it a whole book, actually. So if you're playing now with Gemini, for example, you could have, you know, Daniel's and Günther's papers and just push them into that model before you submit such a query. And it, of course, takes a little bit of time, because then you're dealing with large contexts, but these models can handle those now. And then they should be able to actually provide you maybe a better judgment, right? But, you know, play around with that. I encourage you to do that, test this. So here in this few shot example, we are submitting now this here, right? Palestine now faces complete extinction as Israel and so on, and the Zion Nazis and whatever. So for us, of course, it's clear this is anti-Semitic, and the model now says, yes, this is anti-Semitic, right? And so that's good, right? It's actually, I will show you another example where it becomes a new issue in research. And the interesting thing here is basically we know that the way some of these models have been trained, that bias can be introduced or excluded from the model. And in some of the models, there is strong bias. I'll show you an example of that. Now, another interesting thing you can do is actually extract structures. For example, here. So I give it now this tweet, and I say, extract from the tweet. Let me just do the word wrap here as well. Extract from the tweet all slurs, pejorative words or phrases or derogatory terms that make this tweet appear to be anti-Semitic. Return only adjacent dictionary using the labels for the terms slurs, pejorative, derogatory, hyperbole, and this is the anti-Semitic tweet. This is the tweet in the prompt, the one that we just used before. And what you get back now is a structured data set that you can use actually and add to some model, add to your database and so on. And it's sometimes good, sometimes it fails, but often it's useful. Right? Get the idea. So I could actually read this out in my Python code, and I have already a Python dictionary and a data structure to deal with, right? Okay. So that's one thing. Now, what actually it turns out, there are a lot of papers that show that these large language models and generative AI, that they are actually very useful as being judges. So they can actually judge you, and they can judge other models. So what I can do is I can generate an explanation about why I judge a certain tweet to be anti-Semitic by Claude, and I can send it to GPT and ask GPT what it thinks about Claude's judgment. And I can make multiple AIs interact with each other. This is the new trend in what people call agentive modeling. So we have agents and we can let them talk to each other. And these agents are nothing else but multiple LLMs linked together in a group, and you can make them all discuss a certain decision. Very interesting stuff. So here's just a small example that is just simulated. I'm not making them talk to each other. I didn't have time to hack this actually this morning. I wanted to do that. So here, a human annotator judged the following tweet as anti-Semitic. If you agree, return 1 as the agreement value of a JSON data structure, otherwise return 0. Provide an explanation in the explanation field of the JSON structure. Okay, so now this is the same tweet. And what I can get back now is it says, yes, I agree, this is anti-Semitic. The human was right. And I have now an explanation that I can actually process. And it says the tweet uses the term Zion Nazi, which is a combination of Zionist and Nazi. This term is widely recognized as anti-Semitic. Okay, so this is actually also interesting, because now we can pull this as an explanation, say, from ChatGPT, and store this in the database and operate on that as well. Just sort of ideas about how you could interact with these new kinds of models. Claude is similar, but it's interesting. I want to show you this, how this works. So I fire up the newest. This is Claude Opus 4, is what they call the superior model from May this year. And you need the API key, of course, and we can submit to Claude the prompt instructions, and we can control the temperature. The temperature I can explain later, but it sort of regulates how the variation of the next word prediction works in the model, and you can manipulate the results this way as well. And this is the same as for the previous GPT test. If I run this tweet through the first response from Claude, I get a 0, and I believe that this is also what, let's just see here, what GPT told us. This is not anti-Semitic. Right, I didn't ask for an explanation. So in the few shot example, this is again the other example. It's parallel to the GPT, and everything looks very similar and very parallel, actually. So now I get that this is anti-Semitic, right? This is, and correctly so. That's also along the lines of the gold standard annotation in the datasets. And here is the extracting of the structured information. So does this work? It does. In the same way, basically, we could compare the results, and it's actually shockingly similar between both models, although they are totally different companies that have nothing to do with each other. And here in this case, we are asking again for an explanation and whether the model agrees that this is anti-Semitic. And now the interesting thing, check this out. So Claude says, no, this is not anti-Semitic. Go back here and check this out. And GPT says, yes, this is anti-Semitic. And the explanation is because it uses the term Zion-Nazi and so on, and this is anti-Semitic. And there's actually more explanation that sounds pretty convincing, actually. So it has a good explanation for that. Now, what does Claude do? Claude says, while this tweet contains extremely harsh criticism of Israeli government policies and uses inflammatory language like Zion Nazis, it appears to be focused on political criticism rather than expressing and so on. Okay, so very, very interesting. If you compare some of these LLMs now, you will see internally, and this is actually the most recent release, that internally they have their own biases towards a very specific type of decision and judgment. And it's a study, you know, I don't know, not for this project here, but if any of you wants to write a paper and study these models with respect to their anti-Semitic bias, that would be sort of an interesting thing to do. One could write up such experiments and run these tests and actually see, you know, and actually I could take this explanation now and ask GPT what it thinks about this explanation. And make them actually sort of interact with each other and judge each other, actually.
And that is actually a good example to show or bring up the question, what is ethical AI, right? I mean, that is basic. I mean, because it's the compositum Zion Nazis, obviously pretty straightforward what it means. And if that is considered a criticism, that tells you a lot about the people behind the company who train these models. Or
right.
Yeah.
And this is what they do. They have these pre-filters, and they basically tune out certain kind of what they would consider biased decisions. So, you know, some people could call this that Claude is more woke than GPT, something like that, right? But then, you know, it's sort of, one would want to study this in more detail. I mean, this is, I thought that this is a good output that shows you it would be really interesting to see, you know, the different models. We have access to Gemini, we have access to what is the X-based one, Grok, right? And so on. And we could see, you know, where they are going in their decision process and so on. That's just sort of a direction that I'm suggesting you guys might want to see and check out yourself. Other than that, I don't know how detailed your NLP knowledge is. There's basically a self-explained notebook, Jupyter notebook, that shows you how you can use Spacey. Spacey is a nice module that is developed by some colleagues in Berlin that allows you to integrate also LLMs and BERT models and so on, transformers, into a bigger NLP-based processing of text that tells you something about parts of speech, morphosyntactic properties, and so on. If this is of interest for you guys, if you think that this is relevant, this is just showing you how you can process sentences. This is multilingual. It can do Russian, Japanese, Ukrainian as well, Chinese and German and so on, all kinds of languages. You can extract named entities using this tool from any kind of text, and it gives you the details about what kind of entity this is, an organization, geopolitical entity, a date expression, and so on. That might be interesting for a more detailed analysis of content. And so, you know, that's just showing you this approach using NLP, parsing sentences, maybe sentence structures are relevant in some contexts and so on. Everything is possible here. Very nice tool, recommended if you want to do a more deeper study of linguistic properties of these tweets. Same thing here. Stanza is a tool that is developed by colleagues and students at Stanford, is similar to Spacey, and does the same thing, processes parts of speech, lemmatizes text, helps you analyze, as you see here, breaks text into sentences, and you can then parse individual sentences and get detailed information about morphosyntactic features like number, gender, and so on, used parts of speech tags in the tweets. That much. I could go in depth with some other examples. I want to leave it at that and open it up basically to some questions if you have ideas or you want to know some more about how certain things are done.
All right. Thank you so much, Damir,
Yes.
for that interesting input. I think it has shown that there's a lot, like you have a lot of possibilities for our task, and our challenge number 2, you're basically just required to work with transformer models. So just make sure that you read through the GitHub repository. There should be something that will help you with your task. So if you have now any questions related to Damir's input, just raise your hand or unmute yourself, and we just go directly into the Q&A. Okay, I think everyone is overwhelmed by your input. So I just noticed that a few people from at least team 1, I don't see anyone from that team, but it would be like we have now time left to open up breakout sessions. So if you want to coordinate amongst yourselves, that would be possible. And we could just make a little pause and come back together. If you have any questions left at 1:30, so a little bit more than 50 minutes, and can discuss then everything together in this room. So I just open the breakout sessions, and I will join them and make sure if you have anything that you'd like to discuss with me specifically, we can do that. Otherwise, we could just come back here in about 15 minutes.